Alright, this is the second page of that review that I was working on. Excuse the noise of the children in the distance. This section here is all about using vertical and adjacent angles to write and solve equations for missing pieces. This first problem here, what you've got is it labels this top angle as 37, it labels the bottom angle as x, and it tells you that the two of them together are 54 degrees. So whatever x is plus 37 degrees should add up to 54 degrees. Now the work you need to do is take away the 37 from both sides. You get x equals, let's see, 14 minus 7 is 7, and then 4 minus 3 is 1, 17 degrees. So the two angles that you see, the smaller angles, you've got one that is 17 degrees. Of course, there's 37 degrees. And altogether, you have the 54 degrees. Really, the only one you didn't know was 17. I don't know what I have to write all them down for. This one is similar to another one we did where we have the vertical angles are labeled, but not with exact values. They're labeled with expressions with x in them. So since they're vertical, I know that whatever this is exactly the same amount as this guy. Just looking at it, if 2x is the same as x plus 35, then 35 has to be x. It's the only way about it. Our equation is going to be one angle equals the other angle. And since I have x's on both sides, I'm going to want to be able to have them only on one side. Let's see. I have 2x here and 1x here, so it's easier for me to subtract just 1x from both sides. Not only that, it's going to leave this 35 over here. So whatever x is minus whatever x is 0 plus 35. Now I want to mention this is a problem that people do all the time. When you have expressions and equations, if I'm subtracting x from 2x, I'm not left with 2, because it's not 2 plus x, it's 2 times x. So it's 2 of x minus 1 of x. 2 minus 1 is 1, x. I've got two things that are x. I'm going to take one of those away. What's left is x. So x is 35 degrees. And the angles are going to be 2 times x, that's 70 degrees. And the other one's 70 degrees. Now, hey, if you want to find these other guys we don't know, I think it's best to just do 180 minus 70. 180 minus 70 is under 10. Alright. Over here, what we've got is an angle that's 2x, an angle that's 3x minus 6, and altogether they add up to 78 degrees. So whatever 2x is, plus whatever 3x minus 6 is, you get 78 degrees. So 2x plus 3x, and 2x plus a minus 6, so 2 and 3 is 5x, and then plus negative 6 is just minus 6, is 78 degrees. So let's go ahead and add 6 to both sides, get that down to 5x, and 78 plus 6 is 84. Divided by 5, and x equals, 5 goes into 84 one time, 5 goes into 34 6 times, 0.8, so 16.8 degrees. Alright, 2x, 2 times 16.8 is 32 plus 1.6, 33.6 degrees, and then 3x minus 6, so 3 times 16 is 30, 48, plus 3 times 0.8, so that's 40.4. Minus 6 is 34.4. Yes. Alternately, I could have said what's 78 minus 33.6, and that's going to be, yep, no, I've done something wrong, hold on. because that'd be 68 point. I think this is 44.4. I think I did mental math wrong. I need to double check that one later and make sure with the calculator that I did it right. This is all about classifying triangles, which is not the current standard. This is back from G2. And it's something we've done before. We can find the missing angle because this is 90 degrees. And then these three should all add up to 180, so that'd be 29 degrees. All right, I have three angles that are all different sizes. That means none of my side lengths will be the same. So it's a scalene triangle. And one of my angles happens to be 90 degrees, so it's a right triangle. If I had only angles less than 90, it'd be acute. If I had one angle that was bigger than 90, it'd be obtuse. If two of my sides matched, it'd be isosceles. If all three of my sides were the same, it'd be equilateral. Determine the missing value and then classify it by side and angle measures. Okay, 68 and 58, and then something that's missing. So 68 and 58, and an unknown is 90. Oh, not 90, 180. There we go. 68 and 58. See, 8 and 8, 16. 126. So x is 54. 50, 50. That's 100. 60, 70, 80. Yep. All right. So 54 degrees. Because none of these are the same angle, it's not going to be, it's just going to be a scalene triangle. And all of my angles measure less than 90, so it's an acute triangle. All right. This guy here, we're given only one of the angles, but this line here and this line here means that two of my sides are the same length. So if two of my sides are the same, it's an isosceles triangle. And that means that these guys match up and these guys match up. So if these are the same length, then these have to be the same measurement. All right, if that's the case, then 32 and 32 is 64. That's 180. So x is 116. And one of my angles is larger than 90, so it is an obtuse triangle. So yeah, sometimes you're given that information that your sides are the same length by having just a hash mark through them. Sometimes you're given the information that the angles are the same by having like a hash mark through them like that as well. So determine the missing value and then classify what kind of triangle we got. All right, this one here, again, we got 6 and 6. I know from lots of experience that if I have two legs that are the same and it's got a right angle here, that means that you got a 45, 45, 90 triangle. But let's say we don't know. So these guys, again, go together. So if these are the same, then these are the same. And this is 90. So 180 minus 90 is 90. I have two angles that are the same. They got to add up to 90. So 45 it is. It's another isosceles triangle. And one of the angles is right. So it's a right triangle.